Great. Well, I appreciate taking part in this fifth joint seminar. I think I have attended all but one of them over the years, and we always learn a lot from each other, the JCI side and the ACI side. So I'm very pleased to be here. I'll say to our Japanese colleagues, Ohayo gozaimasu, and to our U.S. colleagues, good evening. So I would like to talk about ACI's efforts to incorporate sustainability provisions into the ACI 318 building code. I'm currently chair of ACI 318 Code Committee for the 2025 edition. And we recognized at the very beginning of our formation of the committee for 2025 that we needed to introduce sustainability provisions that facilitated or paved the way for implementation of more sustainable concrete construction. So I'll be telling you a little bit about that. So these are the parts of my presentation here. It's a fairly brief presentation. I'll first talk about something I think we all know about, which is the overall environmental impacts of concrete construction. I'll talk generally about how ACI is approaching the sustainability of concrete, and this is evolving almost each day. There's some additional activity or initiative started at ACI regarding concrete sustainability. I'll ask and perhaps begin to answer the question, what can the structural engineer do about concrete and sustainability? We do have some new sustainability related provisions in the current building code, ACI 318-19, and I'll talk about what we're doing towards development of the next edition of the code in 2025. First of all, I think this is probably a graph that we have all seen in one form or another. It's the general global content of or concentration of carbon dioxide as measured over a period. In this case, I've shown from the year 1900 till 2018. And the total increase in atmospheric CO2 over that period has been 39% increase, and that is not showing signs of slowing down. So we need to make a very strong effort to arrest this trend. Now, we often hear that as people who work in the concrete industry and concrete design field and research fields, that the production of cement is a major contributor to atmospheric CO2. And that is, in fact, true. You may look at other industries and sectors that supply or produce more atmospheric CO2. But as we see here on this list here, the production of cement alone is, in the top 10 certainly, and has a major impact on total atmospheric carbon. So we can talk about a lot of different metrics and different measures of the environmental effects of cement and concrete production and construction. But to me, the most important statistic of all is this, that each year, more than 4 billion metric tons of cement are produced, and that production accounts for 8% of the global CO2 produced. This number has, there are various estimates ranging from about 5.5% to as high as 10%. I've chosen to quote here a summary by Chatham House on concrete sustainability, where they cited a figure of 8%. In any case, that's a very large number. And as I see it, the engineers, researchers, industry people, we're a group of very smart people. And if we can reduce the contribution of cement production and concrete construction, if we can even take 1% off of this number and make it 7%, we will have been contributing to the reduction significantly of CO2 in the atmosphere. So, we all have our talents and our ideas and our training, and I think we can do this. We can make a significant reduction if we put our minds to it. So, in my arena as being chair of the Building Code Committee in the U.S., I have been looking around for ways to try to facilitate and promote the reduction of CO2 emissions from concrete construction and cement production. So I'll explain in a moment what we are doing in ACI 318. I wanted to first review some of the things that ACI as an organization has been doing to address sustainability and to explore ways to reduce the global warming impacts of concrete construction. This over the last 10 years or so, if I went through ACI's resources and found these numbers. ACI has produced more than 40 guides and standards related to environmental concerns with concrete. Journal articles, definitely more than 60. These are technical papers. Practice-oriented papers and articles on sustainability. There have been more than 200 online learning opportunities like webinars and recorded seminars, more than 100. And then events that ACI has either sponsored or co-sponsored have been more than 25. And these numbers are even larger today. I first gathered these numbers about 2 years ago. So ACI has very high priority on this issue. I want to highlight one committee that is central to this effort, and that's ACI Technical Committee 130. It's a very large committee as technical committees go because it's a topic of great concern to many people. There are over 100 members. There are 8 subcommittees that address technical issues within Committee 130. And I recommend their main committee publication, which is called Report on the Role of Materials in Sustainable Concrete Construction. It's available from ACI. It was published in 2019. The committee is actively updating that document. I'm not sure when their next edition will be produced, but probably very soon. I'm guessing within the next year or so. So something to take a look at. There's a lot of information in there about how concrete and cement relate to environmental impacts. There is a new committee, just another example of one of the technical committees dealing with this question is ACI Technical Committee 321. It's the Concrete Durability Code. So there's an effort to develop a code that has specific requirements for durability. And I think most people would agree that a more durable building is a more sustainable building, because if a building lasts 100 years instead of 40 years, then that is a more sustainable structure. The longer lived structure is more sustainable. This committee has 15 members. Currently, it was established not too long ago, and just near the beginning of the pandemic. So it's working at its objectives, and we'll see in the next few years what they produce in terms of a durability code. Okay, now a very central question. What difference can the structural engineer make? So by and large, the People involved in ACI technical committees are either researchers or structural engineers or people in the concrete industry. Speaking for the structural engineers, I often wonder what is it that I can do as an individual? I have certain skills. Are they really applicable to this question of sustainability of concrete? And I recognize that I am not an environmental scientist. I just have some very basic understanding of environmental issues. I'm not a regulator. I can't help write rules or regulations related to environmental management. I'm not the architect. When I work on a project, many of the key decisions about a structure are made by the architect. And I'm not the owner of the project. So other key decisions are made by the owner about sustainability goals and so on. So what does that leave for me as a structural engineer able to do in this process? Well, there are a few things, and I'll touch on these here in this list, but I want to emphasize the last bullet item when we get to that one. So simple things that the structural engineer can do is to actively specify concrete mixtures that make use of alternative cementitious materials. We've just heard about a couple different solutions in the previous speakers. It's now possible within the context of the ACI 318 building code to use recycled aggregates, including crushed recycled Portland cement concrete as aggregates. So it takes a little more work, more diligence, and paying attention to the quality and properties of the recycled aggregates compared to using new aggregates. But it is a possibility, and we as structural engineers can suggest that recycled aggregates be used. Traditionally, we have assessed the strength of concrete at a time of 28 days, about 1 month. There is actually no reason why we can't say that the time for achieving sufficient strength is 35 days, 45 days, 60 days. If we can obtain a more sustainable product by allowing more time for it to reach its design strength, I think that is an excellent way for the structural engineer to influence that directly. And it goes without saying that we should design using the minimum possible concrete. The economics of that sometimes work against us doing that because contractors find it less expensive to build if member sizes are repetitive and similar, and wall thicknesses are similar and don't change, column sizes don't change over the height of a building, and so on. But if we take the extra time and perhaps expense to optimize the structural performance of the members that we design, we can reduce the volume of concrete used. And finally, I want to talk about the engineer's role in promoting sustainability provisions in structural codes and standards. That is what we are trying to do now at ACI and within the ACI 318 committee. So I want to describe a little bit about the history of sustainability provisions in ACI 318. The building code for the US for concrete contained no mention of sustainability at all until the 2014 edition. In that edition, there was a very brief mention, a new section introduced titled Sustainability, and it was a very minimal statement that says sustainability considerations are permitted to be used by the engineer in design. But immediately after that, it says, if sustainability considerations are utilized, then they shall not take precedence over considerations of strength, serviceability, and durability. And this was you might say, well, that's not much of a very strong statement, but it was a start, and it was the first part of introducing sustainability into the ACI 318 code. Now, in 318.19, we had additional provisions that moved us further towards implementation of more sustainable practices. In 318.19, we stated that it is permissible to use, rather than just Portland cement and certain approved supplementary cementitious materials, SCMs, it is possible to use what are being called alternative cements. And those alternative cements, whatever they might be, they aren't specified what those alternative cements might be. They can be used if they're approved by the engineer and by the building official. So there has to be approval from both the engineer and the building official in order for the contractor to use some type of alternative cement. This approval to use alternative cements shall be based on test data, and that data shows that the concrete made with the alternative cement meets all the structural strength requirements, fire performance, and durability performance that would be achieved with a Portland cement concrete in this particular application. The other thing that was permitted in 318.19 was the use of recycled aggregates, which I mentioned earlier. This is some commentary about that addition of a recycled aggregate. It's also a warning that in the United States, the material standard for aggregates is the American Society of Testing of Materials, or ASTM C33, and generally aggregates in concrete must meet ASTM C33. It's possible that some recycled aggregates may comply with or meet ASTM C33 requirements, but not perform as desired by the structural engineer. So there's a caution here. It says use of recycled aggregates, including crushed hydraulic cement concrete, in structural concrete requires additional precautions. So it doesn't get very specific. It just says be careful and look carefully at your aggregate sources and so on. In this section, further on in chapter 26, it specifies that if you're using crushed hydraulic cement concrete or recycled aggregates of some other kind, they have to be, again, approved by the licensed design professional and the building official, and they have to meet requirements 1 and 2, which are that the concrete made from these alternative aggregates or recycled aggregates has the same properties, same mechanical properties and durability required that would be produced with non-recycled aggregates. And furthermore, a testing program to verify the aggregate consistency and quality has to be implemented. And most importantly, this testing program has to be maintained throughout the life or the duration of the project. So from the beginning to the end of the project, when concrete is being produced with recycled aggregates, testing must occur to ensure that the properties of the recycled aggregates have not changed over time, meaning when recycled aggregates are produced, if they're crushed concrete, they may come from different sources and be mixed together in one stockpile. And so this ongoing testing is a key part of using recycled aggregates. Okay, on to what we're doing for 318 2025 edition. We have formed a new subcommittee, Subcommittee N, titled Sustainability. It was established at the beginning of this code cycle in 2019. The chair of that subcommittee is Shana Kelly, who is an expert in environmental aspects of concrete production. And she's a structural engineer and professional engineer who understands both structures and environmental impacts of concrete. So we're very glad to have her in that position. There are 12 voting members on this committee. They have 6 task groups. There's some overlapping membership, but they're working on different aspects of sustainability provisions for 318.25. So what will these provisions look like? Well, traditionally in the ACI 318 building code, new provisions are introduced through an appendix, which then finds its way into, perhaps in the next edition of the code, into a numbered chapter within the code. So what Subcommittee N is writing is a new appendix on sustainability. And it's very important to understand that this subcommittee is establishing provisions that will facilitate sustainable design, specifically approved methods for assessing the environmental product declaration or embodied carbon in a concrete mixture. Also, the life cycle analysis of carbon in a concrete structure under the ACI code. What this committee is not doing is establishing or suggesting limits for embodied carbon or life cycle, total life cycle carbon related to concrete. That is a very local sort of decision, because the achievable carbon content of concrete is strongly dependent on the aggregate. So when an area has a certain type of aggregate, the producers in that area know what can be achieved in terms of embodied carbon in a certain mixture for a certain strength. But those goals may be much different from, let's say, Seattle versus Florida, somewhere in Florida. The aggregates are very different. So ACI 318 Subcommittee N is not setting standards, but they're setting standard methods to evaluate the environmental impacts of a particular concrete mixture. And those will be in Appendix N. When in a year from now, when we have the full ACI JCI seminar, I'll be able to report on more details of that appendix. For now, we know that they are working on the appendix language itself, and also coordinating with other sections of the code and other technical committees to make sure that there's consistency throughout the code, particularly regarding regulations for alternative cements and the use of recycled aggregates. This is the current outline of the appendix. Again, I can fill in a lot more details in 1 year, because the committee will be probably nearly finished writing this and approving this appendix at that time. So the item 1 is the scope. Where does this appendix apply? Item 2 is what I mentioned earlier, is that it's providing guidance on acceptable ways to measure the environmental impact of concrete. It also seeks to measure the overall sustainable impacts of structural concrete systems, not just the material, but the entire system, including, for instance, thermal mass and how that affects the sustainability of a project and its overall environmental impacts. And then a section related to resiliency to describe how resiliency, that is the extending the life of a structure extending its resistance to extreme events, say, relates to sustainability. So those are the four main topics that will be in Appendix N. And as I said, I'll be able to give you a lot more detail in about a year. I just want to point out, if you are interested in this topic, there are some resources described here. ACI 318, you can look at the current provisions that I outlined a little earlier. The ACI Committee 130. ACI 201 is the Technical Committee on Durability, and ACI 321 is a code writing or a standards writing committee on durability. So since durability and sustainability are linked, you may be interested in those. I also encourage you to go to the ACI abstracts search database on the ACI website, which allows you to enter keywords, and that will bring up all kinds of resources on practice-oriented papers and articles such as those published in Concrete International, the Structural Journal, Materials Journal, and there are also ACI events, conferences, webinars related to sustainability. So I encourage you to look into those if you have further interest in this topic. So I just want to finish by returning to this quote that when we're talking about concrete construction, cement production accounts for 8% of global CO2 emissions. And if we, a group of what I like to think of us as smart people and clever and inventive and creative, if we can reduce this number, and I think we can, we'll have a big impact on global warming. So leave you with those words of encouragement. And that is the conclusion of my presentation. Thank you.
Thank you very much, Andy.
I have a question.
Yes.
So actually, this session is have several objectives to learn. And the second one is describe how industry code and standards are changing to allow the greater sustainability to be introduced into the design process. So my question is very related to the design process. Especially many topic is related to the material design. It can be produced by the alternative cementitious material or recycled aggregate. But you showed lastly the resilience. So that is one of the contribution from the structural point of view on the sustainability to reproduce the more resilient or the more durable structure can be produced by the structural engineers. But that topic is very related to the other provisions. For example, this seismic or other structure point of view. So how to handle to this topic gathering into the Appendix N or appendix related to the sustainability or related to the other provision that is previously contributed for the more conventional concrete structures.
And I assume you're asking me that question. Is that right?
Yes.
Yes. Okay.
Thanks for taking that one, Andy, because I don't have a good answer.
Well, I have an answer. I don't know if it's a good answer, but I'll give it. Yes, particularly with regard to durability under extreme events, and those would include those would obviously include earthquake, extreme wind, and well, I'm not sure what else to include. Those are the two most obvious ones. ACI is constantly working on trying to place the philosophy of design of structures for wind and seismic into a performance-based framework rather than a prescriptive framework, a performance-based framework, which allows engineers and clients to decide on what type of performance under, well, any event, but particularly extreme events, how the building will respond. Performance-based seismic design has been a topic of discussion and research for quite a long time, definitely the last 25 to 30 years. The other area that we, as a structural building code, are trying to support is performance-based wind design. And wind design is being addressed currently in this code cycle by another new subcommittee, sub W for wind, who is, they are writing a guide to designing for wind, for extreme wind events in a performance-based manner. And in this concept of performance-based wind design, actually for extreme events, there is a consideration of minimal nonlinear behavior. That is just minimal, perhaps, yielding of reinforcement. And that this is controlled with various considerations of the design. But by doing that, we're able to not only improve the economy of construction, particularly of tall buildings for extreme winds, we're also able to more rationally predict the design life or the durability of buildings to extreme wind loading. So rather than just complying with prescriptive provisions for wind design, they would be more performance-based. So that's one example of what we are doing within the rest of the code to try to enable or facilitate the implementation of more rational methods for determining the level of durability of a structure. We're also doing things with environmental exposures, like reclassifying the chloride exposure, sulfate exposure, and so on, to provide a better system of classification which relates to the durability of the concrete and reinforcement itself. So I don't have a concise, clean answer, but I will say that it is our philosophy with 318 to try to facilitate a more rational and predictable approach to the durability of concrete structures.
Yeah, thank you very much. Yeah, I'm very looking forward to seeing the new appendix.
Okay, me too.
Thank you very much. Thank you very much.
Okay.
Thank you, Keith.